Welcome to T equals, or this equals. So the idea is that this equals answers, this equals explanations about maths.
So we're going to do a little review of some concepts that we did discuss earlier this year about dimensions of shapes. And we're going to tie that into a lesson or a new unit about angle relationships. So we're going to start with a little bit of review, and here we are with a single point. And as you can see, we have a single point just here. And we know from previous lessons that these are the properties of a single point. A single point has 0 dimensions, yeah? It actually has no dimensions. And a single point has 360 degrees around it. So we can just draw on there. 360 degrees, yeah? And then the next concept we're going to review is a straight line. So this is what a straight line looks like. Make sure when you draw diagrams of your straight lines that you include these arrows, because those arrows imply that the line goes on for infinity, which is the definition of a straight line, if you guys remember from your previous cube activities. So we've just got a couple of properties here. We won't write them all, but a straight line has 1 dimension. So 1 dimension, and a straight line has 180 degrees on either side of it. So let's just draw that. So that means that a straight line, if you take either side of it, it has 180 degrees. And on this side of it, it has 180 degrees, which makes sense, right? Because we could also draw a straight line through this single point here. And we know that around the single point is 360 degrees, so the straight line cuts that in half, so it'd be 180 on either side, just like this. Okay. So here we have a straight line, has 180 degrees on either side of it. This is called the angle sum of a straight line. So the angle sum of a straight line is 180 degrees. Now we're going to be looking at intersecting lines and vertically opposite angles. So when we have intersecting lines, it just means 2 lines that cross each other, right? So when lines cross each other, they're called intersecting lines because they literally intersect. And then the next thing is that intersecting lines have 2 pairs of vertically opposite angles. So I think it's really important to highlight this vertically opposite angles, because that's sort of a vocabulary term, vertically opposite angles. So in this one, the pairs of vertically opposite angles are angle A, and angle B. And then also there is angle X and angle Y. So I've just thrown in this little bit of notation here. Whenever you see this is a shortened way or a mathematical notation for writing angle. Now, another interesting point about vertically opposite angles, yeah, is that they are always equal. Vertically opposite angles are always equal. And I'm just going to highlight that vertically opposite angles in red again, just because that is definitely vocabulary. They're always equal. So we can say that angle A equals angle B, and angle X equals angle Y, always, because they're vertically opposite. So whenever you have intersecting lines, it creates these 2 pairs of vertically opposite angles, and you know that when they're opposite each other, they're always going to be the same.